Welcome class. So now I'm going to start that next reducing reagent, that is hydrogen transfer reducing reagents, same hydrogen transfer reducing reagents, that is L selectrides or K selectrides. L selectrides and K selectrides. This is also a hydrogen transfer reducing reagents. Hydride transfer reducing reagents. It means that hydride will be it transfer hydrates for reactions. Hydride transfer reducing reagents. It means that H minus will comes for the reactions. Okay. Now, so I have discussed that all the hydride transfer reducing reagents. Firstly, I talk about of that lithium aluminum hydride. This is also hydride transfer reducing reagent. It means that from here we will get that H minus, and similarly I said that let's say it's dival H. Here also we'll get that H minus, and I have also discussed NaBH4. Here also we'll get that H minus, and now the fourth type is I'm going to discuss now, that is L selectrides or K selectrides. Here also we will get that H minus. Okay. Now this is important to know the structure. So to distinguish all these things, we say that the structure here, that lithium will be, that lithium metal will be there, with that this aluminum with 4 bonds for hydride will be there, and this is it, the negative charge, and this from here we are getting that any H minus charge. Okay. Similarly dival H, what will be that? Here also similar H bond will be there, and 2 isobutyl will be there. Sorry, isobutyl will be there. This is the structure of this dival H. And now for case of NaBH4, this is the same. Like here, instead of ALH, here we have that ALH atoms. That means that bond between that aluminum and hydrogen. Here also bond between that aluminum and hydrogen. Now for this case, what will be that? Here that boron will be there. Okay, this is the, all are the electron deficient groups. So the boron family, boron. Okay, here aluminum, like that. So here we have that BH bonds. Okay, this group will be there. Similarly, L selectride and K selectrides, for this the structure will be that here what will be that? Here also the boron will be there. Sorry, the boron. Okay, and now instead of that 4 hydrogen atoms here will be there sec butyl will be there. Sec butyl means that that will be the secondary butyl, like here. Now so butyl means 1, 2 and 3. This is the butyl. This type of groups will be there, and again okay, another butyl, methane, ethane, propane, butyl. Okay, now 1 hydrogen atom will be there. So from here what we notice here, that for lithium aluminum hydrides, what you notice that here we have that ALH bonds, and what we say that ALH bond, this is 3s and 3p, and this is 1s. So size difference will be there. Okay, so here what we see, that size difference is high. Okay, similarly here also ALH bond is there, and here also we have that this is 3s 3p and this is 1s. Here also size difference is there, but what we see in here, that here BH bond is there, It means that this is 2s and 2p and this is 1s. So size difference is less. Here also size difference is high. Here size difference is less. Here the size difference is less, or we can say that comparable. Or here also that same things, BH bond is there. This is 2s and 2p and this is 1s, and this is also the same, that size difference is less or comparable. So from here what we notice that since these are that whenever that size difference is high, it means that there will be a less closely they will be bind, means that the bonding will be that the overlapping will be the less, means overlapping is not good. Here what you see that, so here size difference is high, so overlapping of orbitals is less, so it means that more reactive. It means easily hydrate transfer occur. Same things here also, that overlapping is here also LH bond, so overlapping of orbital is poor, so this is also more reactive, and hydrogen transfer easily occur. But for this case what we see in here, that overlapping is good compared to this. Okay, so overlapping is good. It means that this will become that less reactive. So I say that whenever less reactive, it means that it will be more selective, and here that hydrogen transfer is little tough. The same thing with this also, because here also that BH bond. Okay, the same things with that overlapping is good, so this is also less reactive, and overlap and hydrogen transfer is little difficult. Okay, the same thing. So what we've seen here, that these are the four hydrogen transfer reducing reagents. Now, so from here what we notice is that this is a strong reducing agents, this is a strong reducing agents, and here hydrogen transfer is easily possible, so it will be a strong reducing agent. Then that, so it will reduce that all types of bonds, like if we have esters, amides, aldehydes, ketones and nitriles, everything will be reduced when we are giving the lithium aluminum hydride, because it favorable that ease of releasing hydrate, means H minus. Okay, the same things for this dival H. Here also ALH bond is there, so here also that the size difference is high, means that H minus can easily release, and compared to this become that less reactive. Reason is that here only one ALH bond is there. Okay, and here what is that bulky groups are there, so due to this become a little less reactive than this. First this will be that highly reactive, first this is highly reactive, after that this will comes, because here that bulky groups has came and one LH bond is there, so this become less reactive than this. But here also, since this is the ALH bond, so it is also able to reduce nitriles, esters, amides, and that is reduced to that aldehyde groups. Whenever we have that works to reduce up to aldehyde groups, on that time we used to use the dival H. Okay, it is that selectivity is given by this bulky groups. Okay, and one hydrogen atoms, one ALH bond is there, here 4 ALH bond is there. Okay, so this makes that it's become more selective. Okay, and it will reduce up to aldehyde only. Okay, yes, if you are giving a high temperature, then that will reduce to alcohols. it will directly reduce alcohol. But if you give low temperature, then that ester will stop at the aldehyde stage only. So first it will be highly reactive, after that this. And now coming to that NaBH4, here that BH bond is there. Since that overlapping is not is good compared to this, so this BH bond is that releasing of H minus is little tough, because that overlapping is good. If they are good overlaps, they are actually overlapping in very good way, which means that releasing of it will be difficult. So this become a less easily to remove this H minus. It means it become a less reactive. That's why this NaBH4 not able to reduce that kinds of ester groups and kinds of amide groups and nitrile groups, because it become a less reactive. Okay, and this NaBH4 is mainly prepared for the reductions of aldehydes and ketones and like tosyl hydrogens that I have already discussed. So this will become less reactive than this divalproenes, this NaBH4, due to this BH bond. That overlapping is good. Now we are going to come to that next reducing reagent, that is L-selectrides or K-selectrides. Here what happened, that same BH bond is there with that bulky groups H come. Means one BH bond like this, from this lithium to here, that one LH bond is there with that bulky groups comes. Here also the same things, that same that boron BH bond is there with that some bulky groups H comes. It means that it become less reactive than this one also, NaBH4 also. With that it become a less reactive and it is become a more selective. Okay, now another concepts are used here, that is that HACCP principles, that is soft or hard, that is hard soft acid base, that is whether it is a soft reagent, whether it is a hard reagent, whether it is a soft nucleophile or whether it is a hard nucleophile or soft electrophiles or strong electrophile. So that HSAB principle is play important rules for kinds of L-selectride and K-selectrides, because now it become a bulky groups, and due to this bulky groups, this BH bond, although this is also a not this is have a good overlap, so it become a that is that H minus, releasing of H minus become little tough, so it become a less reactive with that bulky groups H come, so it become a soft reagents. Okay, so now if I talk about of that whether HSC principle, whether this is a soft reagents or hard reagents, so this lithium aluminum become this due to this lithium metals, this become a hard reagents. So what do we say, that hard and soft, how will you classify that? By looking these metals, this metal, since that size is always, that lithium size is small with that positive charge H chem, so this become a small molecules, I mean small atoms. Whenever it become as much as it become it is small, that become a hard reagent. So due to this metal, this lithium plus, this become a hard reagents. Now coming to this, here that metal is not there for that ALH bonds, here metal is not there, so here we will not discuss about of this hard or soft reagents. But whenever you are going to come to this NaBH4, for this case Na plus, and this become a compared to this become a, so whenever HSAB principle, this will be discussed with comparison of this become a soft. Okay, so this is a relative concept. HSAB principle is a relative concept, and this Na plus compared to this, it become a soft reagent. So this become, here that Na plus will be there, this is that minus, and here Na plus is there, and this become a soft reagents. And whenever you go into that K-selectride, L-selectrides, okay, so now better to discuss here K-selectrides and L-selectrides. So K-selectride means simply K plus is there with that boron atoms, and here that hydrogens, and here we have that Okay, this is the minus. Okay, so this is the case electrode, means that potassium will be there, then case electrode. And here L electrode means lithium plus will be there, with that this groups is there. There H, let's say H, because this is the butyl, so methane, ethane, propane, butyl. Okay, and this is the negative charge. This is that case electrode and L electrodes. Note that whenever in the examinations they simply write that case electrodes or L electrode, they will not define this structure, so they simply write that L electrodes or case electrodes. Okay, so in the both case here Li plus, although this is a small atoms because Li with that plus, but due to these bulky groups it become a soft reagent. So this also become a soft reagents due to bulky group. Although here that La plus is a small groups, but since this bulky group is there, so it becomes a soft reagent. Similarly, this K plus, this K plus, although this K plus itself is a large atoms because compared to this, but again here that also this also favor that, here also that bulky groups are there, so all this favor and this become a again a soft reagents. Okay, so what we see that L or case electrodes become a soft reagents and lithium aluminum become a hard reagents, and this that dival H here, that soft reagent, and that reagent will not applicable, here not applicable, and this become again a soft reagents, thus NaBH4, and L selector and K selector become again a soft reagents. So why I am interested about of this soft reagent and strong reagents? So we know that HSAB principle, what this principle says that strong, sorry, that is if we have that hard and hard, they have that good interactions. Good interactions means that will be always they try to do hard interactions, or they will try to do soft interactions. It means that one hard means another they wants to do hard. If hard is occurring, then there will be a good interactions and that will occur. Okay, and if soft, then also that is a good interactions and that will occur. But if it is a hard and soft, then no good interactions and that will not occur. Okay, so this is that HSAB principle. And what said that you remember like this, HS means first hard then soft. So whenever you talk about of this energy, let's say this is the energy diagrams, and now what you say that since we have that mainly CO bonds and CC bonds, these are the mainly possible bonds you will see in organic, and much more bonds are there. Now we are mainly interested about of CO and CC bonds. And for CO bonds, you see that here the electron differentiation is there. This is delta negative and this is delta positive, because this is the more electronegative. But for this case, both are CC bonds. It means that whenever that electron differentiation is there, electron difference is there, it means that there will have a good attractions is there. Whenever there is a attraction is there, means that energy will be decreases. Okay, whenever there is attractions means energy decreases. So if energy decreases means this have that low energy. So it means that here CO bond is there, then CC bond is there somehow here. Okay, because they have that attractions is there. So whenever attractions is there, then energy will decrease. Always remember that attractions decreases energy. Okay, and repulsions increases energy. So here that attractions is there, so energy will be decreases. Okay, so this have that low energy and this have that high energy. So what HSAB principle says, that HSAB principle, so first will be that H means that first will be that H will come, it means that low energy will be that hard. Okay, means we will remember likewise. So first H, so first will be that hard will come, and S means after that soft will come. So you remember from this principle that HSAB principle. Okay, so first since this one we can say by looking this, that attractions means energy decreases and repulsions means energy increases. Here either repulsion or attraction, nothing is happening, so here attractions is there, so this energy is low and this is high. So how we remember that which is hard and soft? So remember that first HSA principle, first H then S. So first here we are going from here to here. Okay, so first will be that hard, then we will have the soft because of this alphabet. So remember like this, HS means first hard then soft. So low energy means hard and high energy means soft. Like we say that less size means hard and high size means soft. Means whatever that high, that will comes always that soft, and whenever that is a small or low energy, that will always comes to that hard. Okay, so this is the hard and this is the soft. Okay, so now we understand that why I am interested about of this hard and low. So first we will classify that. So reagents can be two ways we can classify it. One is hard reagent, another is soft reagents. Okay, one is hard reagents, another is soft reagents. So what are that hard reagents? So in this hard reagents that will comes, so that I have already discussed here, that is, here I says that like this lithium, due to that small size of this lithium, this become a hard. So LiLH4 whenever there, then this is a hard reagents. Okay, similarly that if you have that reagents like whatever I said here this divalent hard soft concept will not come because here no metal is there, here Na is there. Okay, so but Na, because of that Na plus, this become a soft reagents. So always you do that comparisons to compare to lithium aluminum hydride, this becomes a soft reagent, that NaBH4. But note that whenever cerium is there, okay, on that time it will also become a hard reagent. Now this is a soft reagent. Okay, we are doing a basic differentiations. And if you have that hard reagent, like if you have that Grignard reagents, because here we will discuss after this reagent, that is CH3 minus metals, something like carbon ions will comes, so that become again a hard reagents. And in that soft reagents, if you have that R2CuLi, okay, so this reagent also falls in the soft reagents. Also here that our reagents for this class, that K selectrides or L selectrides, this also falls in the soft reagents. Okay, so soft reagents are NaBH4 or organolithium reagents, this R2CuLi and K selectride or L selectride, these all are fall in the soft reagent, and this fall in the hard reagents. Okay, now what type of questions will ask? Let's say if we have the groups like, let's say we have the groups CO, and let's say we have that this type of groups, and now we have that bonds. Okay, now we are giving a one groups, let's say I'm giving here that lithium aluminum hydrides, so this also give that H minus. Now again here I'm giving that K selectrides, or L selectrides. Then what we will do here, so what we understand that this is a soft reagents, sorry, this is due to Li plus, this become a strong hard reagents. This is hard, and this case red here also we are getting that H minus, and this is due to this bulky groups, this become a soft reagents. Okay, now here that what you say that whenever this CO, that CO is the, that is comes from hard to soft. Okay, because you see that CO and CC, and you say that past H SAB, so I'm talking about past H, then S, so this become hard reagent, so this is hard, and this is that here carbon, so this is the CC bond, so this comes in the soft. Okay, now we understand that hard has good interactions and soft has good interactions. It means now we say that this hard, so this will attack to here, because hard will be the good interactions, and this is the soft, so this H minus will attack to here. Okay, so now how the product will fall? Okay, so how the product will come, I will do again here. Let's say here CH3, and here now we are giving that LiLH for, then how here we are giving that K selectrides or L selectride. In the exam they will simply write that K selectride or L selectride, they will not write that structure of K selectride or L selectride. Okay, so now if we giving that lithium aluminum hydride, then this is the hard and this is the soft, and this is the hard and this is the soft, so this will attack, this hard will attack to that hard, so and then it will become like this, so it will going to be O minus, and here we have that H, and here we have that CH3. Okay, now if you do that hydrolysis, then that will becomes OH, this will become CH3, and this will become H. Okay, now same things here, if you attack here, then this is soft, so this is the soft, so it attack to the soft, so this will attack to here, then this will shift it to here, and this will shift it to here. It means that it will becomes like this, here bond will comes, and this is O minus and CH3. Okay, now if you do that hydrolysis, then we will get that OH and CH3. This is the final product for this. If you give these reagents K selected, L selected, and if you give that LH for, this will be the final product. Okay, so in this way we can say that where that hard will have the good interactions, means always hard, then it will try to attack to the hard, and if it is soft, it try to attack to the soft. Okay, so if we will solve that question so that we clear more. Let's say the past questions. In this, what we given that lithium aluminum hydride, and they did the hydrolysis. So now what we'll do here, that this lithium aluminum hydride, since this is the hard because of this lithium Li plus, and this CO is the hard, so this will attack to this hard. Okay, so this will attack to here, means 1-2 additions will happen. Okay, one thing that whenever this, let's say if we have these groups, okay, so always start the naming from here, 1, 2, 3 and 4. Okay, so whenever you're giving that lithium aluminum hydrides, it means that hard reagents, then 1-2 additions will happen, means another, we say that hard, other also you can say that hard, or this also can say that 1-2 1,2 addition reactions. Okay, this is also called that 1,2 addition reactions will happen. Other case, that if we give here that, let's say L selectrides or K selectrides, or you give that NaBH4, on that case one, what will happen, that this 1 2 3 4, so 1 4 additions will happen, that is, or you can say that soft, or we can say that 1 4 addition reactions will happen, or this is also called that conjugate, because this is going to shift, this is in the conjugate, so conjugate addition reactions, conjugate additions, that is conjugate. Just a minute. So this is 1 2 direct additions, 1 2 direct additions. Okay, and now this is the 1 4 addition reactions. Okay, so 1 4 addition reactions, or 1 4 conjugate additions, or you can say 1 4 additions, or this is also called conjugation additions, or also this is called that Michael addition reactions. Michael addition reactions. So sometimes it says that Michael addition reactions, means we understand that this is 1 4 addition reactions, or soft addition reactions, or conjugate addition reactions. Okay, because this is 1 4. So this 1 4 additions also called that Michael addition reactions. Okay. So now here, if you attack to this, then what will happen? That this will do that 1 2 addition, 1 2 direct additions will happen here. So product will be that is that H will come here, and this will become O minus. Okay, and here that double bond will be there, here pH. So after hydrolysis, this will get that. So this is the final product for these questions, and H is not mentioned, then this is the answers. Okay, now if we are doing that L selectrides, then what happened, that now this will become soft reagents. So this will attack to this soft, so it will attack to here, it will attack to here, means here this also releasing H minus. Okay, so this H minus will attack here, it means that here H will comes, and pH is already there, and this double bond shifted to here, and here it becomes that O minus. Okay, now we are doing that hydrolysis, on that case here we will get that H bond. So this is the final answers for these questions. Now in these questions, one more thing, that questions I have not. Okay, now if we are doing that hydrolysis, but now instead of that, if I giving that, this is the very maximum time they ask that methyl iodide is there, now what will happen? For this case, what will happen, that so this will attack to here, so here H and pH is there. Now this double bond is shifted to here, and this become O minus. Now we are giving that MEI. Okay, after L selectrides we will get this, and now we will get that, we are going to give Mi. So whether it will attack to direct here and this will down, or this can be the possible that this will shift here and this will attack. So two chances is there. One is that going to shift it here, and directly that will attack. So OMI, Mi means methyl, that is CH3, or it will comes to that here double bond is there, and here we have that pH. This or another chance is here, that this will comes and this will attack, it means the double bond O, and here we will have that CH3, and here we have that pH. So which is the expected product if that methyl halide will give. So not that here, that here if you forming, then OC bond is forming, and here what bond is there, here C, so CC bond is formed. So note that OC bond is not so stable, CC bond is stable. Reason here that that electron differentiation is there. So CC bond is the more stable and it is a strong bond. Okay, so this is a strong bond, and this become a weak bond because of this electron deficiency. It means that this will not form. This will not form. This will be the uh, final product for this type of questions with methyl hydride there, because CC bond is strong and OC bond is not strong. So they want to make confused, like giving this methyl hydride. So which bond is formed? Whether here CH3 will go or CH3 will form here. Okay. Another questions that if this type of stereochemistry is mentioned, then always if any groups if stereochemistry is mentioned, then always try to always make that how it actually exists. Like if you have that cyclohexenes, if you have that cyclohexenes and if you given the stereochemistry, then these cyclohexenes actually exist in pair form. After that, make that these bonds, this type of bonds. Now this is a 5-membered ring. So this 5-membered ring is exist in a envelope form. Envelope form in the sense this will be like this. Envelope form means this will be there. This after that this is coming like this. Okay, this is the envelope form. That 5-membered ring is actually exist. Actually exist in envelope form. Okay, so whenever stereochemistry is mentioned, first convert where it actually exists, because stereochemistry will be depend only stereochemistry we can give the answers actually if you say that what is actually it exists. Okay, so here stereochemistry is mentioned, so convert this 5-membered into where it actually exists. And now after that I have already discussed that it is above, then we say that indo exo. Okay, so equatorial and axial, so this is above, so above will be like this, above will be like this. Okay, now we are giving the LiLH4. So this LiLH4 here which will attack H minus. Okay, and here R means here let's say that CH3 groups. It means here let's say H and H. So if it is attacked to that this CH3 groups, and now we want to attack this, so where we will attack this H minus. So this will attack to that groups. Sorry, I have forgotten to mention this carbonyl groups. Okay, carbonyl groups also is there. So this is that carbonyl groups, and let's say here will be the R group. So this is that equatorial, and axial will be the down, like that same case like chair form. Okay, so now this H minus will attack to this. This always do that 1-2 addition reactions, and this will attack either in the above or in the below. So this is that in the CH3. So this is like these groups. So what we see that whenever here we see that 1-3 diaxial interactions is happening or not, that we will look here. Okay, so here we see that 1, 2, 3. So no 1-3 diaxial interactions is there. So it will attack to that in equatorial, because there is no 1-3 diaxial interactions, but So 1,3 diagonal interactions we will look. Okay, so now if it will attack to here, if it is so first always prepare is that axial attack. So now it will try to do the axial attack. So in the axial attack, is there 1,3 diagonal interactions there or not? 1, 2, and 3. So now here also 1, 1, 2, and 3. So at the 3 positions there is no any groups is there. So we can do that axial attack. Okay. So this is going to be that this will attack from this H will be here, and this O minus will goes to like that. Okay, and this we have that CS3 group. So this is the final product for these questions. If only that lithium aluminum is there, hydrolysis there, then we will do that. If that group is already OH is there, then always assume that hydrolysis is done by yourself. So you have to do hydrolysis by looking at the questions. Okay, because always that hydrolysis will not mention. Now we are going to give that L selectrides, because now this L selectride is a bulky groups. So what it will do? So now I have converted into this form. Okay, so since this is always a bulky groups, and it will do that 1 to 1 for additions, but here since that conjugation is not there, so this is always attack here, because here conjugation is not there, and since that here this is a bulky group itself, so it will attack from that yes, after convert of this, convert into that original form. Okay, because in the questions original form will be there. Okay, so this is going to be sorry, this is going to be that here we have that this is the down, so OH, and here we have that R group. Okay, now in these groups what we say that it will all since this is a bulky groups, and bulky groups always do that that is equatorial attack. So this will be going to be, so it will attack from that here OH, then this will attack from that below sides, because this is a bulky groups L selectrides or K selectrides, because this is bulky groups, so always attack equatorial. Okay, so equatorial means this will H minus will attack these positions, and O will be like this. It means that this is going to be converts. Here we have that O minus, that is after hydrolysis OH, and here we have the H, and here we have that this R group. So if you convert into that original form, then this is going to be that O will be that like this OH, and this is also groups. So this is the final product if that K selectride is there. Okay, so today up to this, in the next class we will discuss more about of the reducing reagent. Okay, thank you.